sometimes you'll be asked to characterize an ellipse, give it certain key features about it. In this case, we're given the vertices and one of the focus points. And I think it's pretty easy to do it in this form, rather than a jumbly equation that you have to turn into standard form. This way, we can just look at the key features, pull out what the center of the ellipse is, what its different semi-major and minor axes are going to be, and then write the equation. It's easier than completing the square, in my opinion. Anyway, let's get started. So the first thing we're told is we have two vertices. Okay, here's one, here's the other. Now, if those are the two vertices, you can see what's changing between them is the x value. So we must be dealing with a horizontal ellipse. And to find the middle of that, you just take the average of the x values. So that points us to a center point right here. What's the average of negative 9 and 1? Right? You just do negative 9 plus 1, divide that by 2. You get negative 8 over 2, which is negative 4. Okay, so this is negative 4, comma 5. All right, so we've got the center point, and that really tells us quite a bit. Let's see, what else do we need? We need the A and the B values. So for this one, since we know it's horizontal, here's what I'm going to say. This distance right here that I'm highlighting in red, that's going to be my A value. Okay, that's A, and you can see that goes from negative 4 to 1, so that gives you A equals 5. And this other distance that I will do in magenta, this is my B distance, that's the semi-minor axis. So that it goes from, let's see, negative 4 comma 5 to, oh, we don't know. Okay, well, that's interesting. How are we going to find that? Well, what do we have to work with here? We know that C is the distance to the focus, right? C equals from negative 4 to negative 8, so that's going to be equal to 4, right? Now, to figure out what B is, we're going to use this equation. And remember the equation for C squared, the distance squared of your focus. That is the absolute value of A squared minus B squared. So in our case, I'm going to get rid of these absolute values because I know that A is bigger than B, right? I'm dealing with the horizontal here, so I can just leave it like this. So for us, that's going to be what? We've got 5 squared equals, let's see if I can write these in the right order. 4 squared, which is C squared. 4 squared equals 5 squared minus B squared. Okay, which if we rearrange, says B squared equals 5 squared minus 4 squared, which is 25 minus 16, which is 9. Okay, so now we have B squared. Great. So let's cross out some of these things and fill them in with what we know. I know that B squared is 9. I know that A squared is 25. Okay, I know the center of the ellipse. Okay, those are my H and K values. Remember, we have to flip these signs. So an HK value of negative 4 comma 5, that's going to give me a plus 4 and a minus 5. So there we go. That's our standard form equation. And I've already talked about a whole lot of these along the way. We said the center is located at negative 4 comma 5. The covertices are located at, well, if you go up a distance of how much? B squared is 9. So if B squared is 9, that means B is 3. We need to go up 3 and down 3 from the center. That means this is going to be negative 4 comma 2 and negative 4 comma 8 if I'm going down and up by 3. The foci are located 4 left and 4 right from the center. Okay, right? That's that 4 value up here for C. So this is going to be negative 8 comma 5 to the left, and if I'm going to the right, that's just going to be at 0 comma 5. Okay, and what do we have left? Eccentricity. Well, remember what eccentricity is. This is defined as the focal length, for lack of a better word. I know that kind of Bigfoot's on some of our vocab from parabolas, but the distance from the center to the focus, and that's divided by the semi-major axis. Okay, so in our case, the focal length was 4, and the semi-major axis was, can't remember anymore, 5. Okay, so for us, that would just be 4/5. And now we can plot everything on a graph very easily, right? If you're looking at the numbers, or you have those, remember that the center was somewhere around, I it was negative 4 comma 5. So like here, there was our center. And the major axis was 5 to the left and 5 to the right. So I'm going to count 5 and go like this. Okay, from negative 9 to 1. Those were given to us, those vertices, negative 5 and negative 1, way at the top of the problem. And the co-vertices, we figured out, were 3 up and 3 down. Okay, so it looks something like this. I'm going to get my vertices on there as coordinate points, my co-vertices on there as coordinate points, and then we plot the ellipse using this nice little ellipse tool right there. It's kind of fun.